Hello, my name is Carl Crawford, and I wanted to introduce you to my latest project, jet engine project. I have always wanted a jet engine. Now I have one. So, what is it? This is a Rolls-Royce Viper 102 gas turbine turbojet engine. Uh, It is from the early 60s. It would have been used in a British Air Force RAF plane called the Jet Provost. The Jet Provost was a two-seat side-by-side jet trainer. So this would have been, if you were training to be an RAF pilot, this would have been the first jet plane you probably came in contact with. So it is approximately 1,800 pounds of thrust. It makes thrust. Thrust comes out the back. It does not drive a shaft. Some generals on the engine would be that it is either a 6 or 7 stage, I can't remember, 6 or 7 stage axial compressor and a single stage turbine wheel. One of the things that drew me to this engine and not any other engine would be that this engine has most of its services, I guess what you'd say, are engine provided. So what that means is the fuel pump is right on the engine. The oiling system, most importantly, is completely self-contained on the engine. And there were not components that were considered airframe components. Because sometimes when you get an engine like this, it has come out of a plane, it's come out of an airframe, but some of the stuff that you would need to make the engine run is still in the plane because it's considered an airframe component. So sometimes engines will have oil coolers, oil scavenge tank, oil tank, and that stays with the airplane. So you don't get that. So then you have to try to go find it or make it. Sometimes it's hard to find information on what it is you're missing in the first place. So it's hard to make something when you don't even know what you're trying to make. So this engine has engine provided oiling system. So you can see there's a small tank here. One thing that makes this oiling system so nice and self-contained is that there's no oil cooler. And the reason there's no oil cooler is because the center and rear bearing sections are total loss bearings. What that means is the oil is not scavenged after it comes out of the bearing and sent back into the system. Now, why would you do that? It makes it very simple. Because the center and the rear bearings are hot, any oil you pull out of there has to go through a cooler to bring the temperature down. So that adds complexity. It also adds complexity in the bearing system to scavenge and collect that oil again. So besides being a pressurized lubrication pump that runs lubrication to the gearbox, the front bearing, etc., and a scavenge pump for that, there are also two small kind of piston pump oil pumps that are on a rotating cam that inject metered amounts of oil to the center and rear bearing. And then once those come out, they just get burned with the exhaust stream. So that appealed to me because it makes it fairly simple. On the other side of the engine is an engine-driven fuel pump. The fuel system on this engine is the style where it's almost like if you were to take it apart, it would almost look like a hydraulic axial piston pump with a swash plate, variable displacement swash plate. That's the other thing that appealed to me with this engine was everything was complete. The accessory gearbox was on it, which has the fuel pump on one side and the tach generator on the other side. The tach generator is kind of the sending unit, if you will, that runs the tachometer, which tells you the engine RPM. On a jet engine, RPM is very important to watch. I would say engine RPM and exhaust temperature are kind of your two. You got to have your eyes glued to those during startups and operations. So this engine spins maximum RPM, which you would call 100% RPM. 100% RPM is 13,800. and that's the RPM of the main shaft. Uh, it was an electrically started engine. It's a fairly small jet engine, so there was an electric starter, and I believe it was a starter generator. But we don't have that because that is airframe equipment. So in this application, the gearbox on the front of the engine, in line with the engine main shaft, was coupled to, and this is it right here. This is what the front of the engine looks like. Was coupled to a drive shaft, which went to a gearbox underneath the pilot seat, from what I'm told. And then that gearbox would have contained the starter, generator, unless those two were the same, which case they would just be in one unit, and the hydraulic pump for control surfaces, landing gear, etc. And so that drive shaft would have come out the center of the engine, and then there would have been on either side of the plane a bifurcated nostril air intake that went into the front end of the engine. I don't have any of that, so c'est la vie. I got to make it. So that's one of the challenges with this engine, is going to be making something to start it. So, and I've started on that, and I'll show you that in great detail in a different video. But that didn't really bother me so much when choosing this engine, because a lot of these engines just you don't get them with the starter. The starters are almost infinitely rebuildable, so those will kind of stay behind to be rebuilt and reused, etc. And they're very expensive to buy. So not having the starter didn't really bother me all that much. Even if I had the starter from the airplane, it would not bolt to the engine, because it bolted to the gearbox, which then had a drive shaft. And in the application I'm going to use this in, I don't have room for all that sticking out the front. So we're going to do something different here. So the engine also has, for ignition, it has two igniters, just kind of like a spark plug in the combustor can section. It did not come with an exciter, which is the box that supplies the spark, or the leads. So I found a box that I think we can make work. It's a dual output box, so it has a place to connect both the igniter plugs. You only really need one igniter plug. You get it started and the flame would travel around to the other cans, but probably good to have both of them firing, get a good clean start. So a few of the things that I need to put together in this project to get it to the point where we can start it and operate it safely are the starter, get the starter system working. You can see I've already built a support frame here out of steel, and I got some batteries up here that I've bought. So we've got to get the starter on there and do some tests with that, make heavy gauge wire, some large relays, essentially contactors, to actuate the starter. We're probably going to do a soft start system. So instead of whacking the starter with 24 volts all at once and possibly breaking something in the engine that's not replaceable, we're going to put it through a kind of a big resistor for a few seconds, let the engine start spinning, let the torque requirement to spin the engine come down a little bit. Then we'll hit it with the 24 volts to get it up to the speed we need to start. So starting system, that's one challenge. The oiling system self-contained. I will probably drain the oil and get some fresh oil, because who knows how long that oil's been in there. So we'll get that filled up. We've got one little oil leak that I need to take care of. I'm going to make some block-off plates for some areas of the engine that went to an airframe component that we don't need. For instance, there's some ports on the 6th and 7th stage compressor that would have gone to windshield de-icing or cabin heater or things like that. Some compressor, you call it compressor bleed air. We don't need any of that. We're not defrosting any windshields. So we'll make some nice little block-off plates for that. Let's see, what else do we need to do? Need to make some bracketry to mount things such as the igniter box, the exciter box for the igniters. We will probably have to make the igniter leads, the spark plug wires, if you will. There's a lot of energy there. So they're usually a stainless braided ground wire with a high voltage wire inside. We're going to have to make something for that because I don't know that I would be able to find the correct length with the correct ends on each end. Finding one for the specific engine and airframe, probably prohibitively expensive. So if we give ourselves a little more latitude there to pick one from a different airframe and make our own cables, I think we'll come out money ahead. We'll need to make some bracketry and things to mount the batteries in our frame. We'll need to make a fuel tank. I think I can get about 35 gallons of fuel tank built for in there, so we'll be cutting up pieces for the fuel tank and welding those, TIG welding, probably an aluminum fuel tank. The fuel will probably use kerosene or diesel. I doubt we'll go to the great lengths of getting a jet fuel because probably don't need it. We don't need the anti-icing and that sort of thing because we're gonna stay at this altitude. Let's hope. So a few things to do with the fuel system there as well. We'll need a lift pump, kind of almost like a diesel truck may have a lift pump to provide 1 to 2 psi just to get the fuel to the high pressure engine provided fuel pump. So for that we're going to use a off-the-shelf diesel lift pump with integrated filter and water separator. We're going to use one from AirDog. Just because it's all nice and compact, I didn't have to source a pump and a filter and this. It's kind of all in one unit, so that's nice. We'll make some bracketry for that, and then we'll have kind of a control panel that we'll put. That will have some gauging, so we'll have exhaust gas temperature. So we'll need to put some probes. We'll probably make an extension. This engine in the plane would have had what they call a jet pipe. This would have been kind of in the center of the plane, so the tail end of the plane's way back there. So there would have been a jet pipe, a glorified tube to get the exhaust to the back of the plane. We don't have a jet pipe. We're going to make maybe an 8 to 10 inch long cone to bring the nozzle down a little bit. We'll put some EGT probes in there. So I digress. Back to our control panel. We'll have engine RPM, oil pressure, fuel pressure, maybe just a warning light. We'll have exhaust gas temperature. That's something we're going to want to watch. And then we'll have lots of switches to flip. So that's kind of the direction we're going on that. And to be able to do a starting test, I still have to make a few more components for the starter adapter. And to be able to do a starting test, we will need to have the fuel hooked up. And even though we're not going to turn fuel on to the injectors on the engine, the fuel nozzles, we'll still want to have the fuel available at the fuel pump, so that, because the fuel is also the lubricant for the fuel pump. So we don't want to do any motoring tests, any turning and spinning of the engine until we've got the lube drained and refilled and primed, the bearings primed, and until we have the fuel system primed as well. We don't want to do any damage to the engine before we even get it going. So, so why do I have a jet engine? I guess the bigger question is, why doesn't everybody have a jet engine? That seems like a more reasonable question to me. So smoke, fire, loud noises, fabrication challenges, electric challenges, machining. This project's got it all. Going into a project like this, you're always going to learn something. Got to discover new things. Okay, what does this need? What speed does this have to be? Just always a challenge. So, and then I guess the last question would be, what is it going in? Well, the frame is going to be self-sufficient. Everything we need for starting will be on this frame: batteries, fuel, drain tank for fuel and oil that drips out, unburnt fuel and things like that. Self-contained. This frame may or may not fit the pickup truck bed of my two-door H1 Hummer. It may fit.